Welcome to FMSP Online Revision. This session is for AQA M1. Topic is Newton's Laws of Motion, and we're looking at June 2011, question 8. So starting by looking at the question, we've got three forces acting in a vertical plane on an object of mass 250 kilograms, and we've got acceleration acting horizontally. So you've got a nice clear diagram there with forces P and Q each acting 80 degrees to the horizontal and giving an horizontal acceleration of a meters per second squared. In part A, we're asked to show that P is equal to 125 times A over cos 80 plus G over sin 80, and that's for 5 marks. And then in part B, we've got to find the value of A for which Q is 0. So let's have a little look at what we might do here. So three forces acting, two of them acting upwards but at an angle to the horizontal, the third one acting vertically downwards. The acceleration is in a horizontal direction, so that means that in a horizontal direction we're going to be using F equals ma. In a vertical direction, since there's no acceleration vertically, then the forces are going to cancel each other out. There's going to be equilibrium in a vertical direction. So if we have a look at that then, so if we resolve horizontally, as I say, we're going to use F equals ma. So the resultant force is going to be P cos 80, that acts in a direction. We're taking this direction to be positive, but it's balanced out by, well, it's not balanced out, but there is an opposing force of Q cos 80. That then is our resultant force, and that will be, using F equals ma, that will be equal to 250 times the acceleration. And if we take out a factor of cos 80, then we have a situation like that, and that now we'll just call our first equation. And then what we can do is we can resolve vertically. So bear in mind there's no acceleration vertically, so the two upward forces will balance out the downwards force. So that is going to be P sin 80 plus Q sin 80, and those two forces are balanced out by the weight of this particle, which is 250 g. And again, if we take out a factor of sin 80, then we end up with what we will call now our second equation. And what I suggest we do now is we've got here in the first equation, we could rewrite that first equation as P minus Q equals 250A divided by cos 80. And the second equation we could write as P plus Q equals 250g over sin 80. So we now have two slightly different equations. If we were to add 1 and 2, those two equations, then can you see what happens? That you've got a minus q and a plus q, and those are going to cancel out, and you'll end up with 2, so we've just gone up here, you end up with 2p equals 250a over cos 80 plus 250g over sin 80. So that's just adding these two right-hand sides together, and that gives us our required result, which is 125, which we can take out a factor of that, over a over times cos 80 plus g over sine 80. So we have the required result. If we then have a quick look at part B, because this time we're told that q is equal to 0. And I've just written the two equations that we had up there. If we put in q equals to 0, then that first equation, if we call that 1 again, and this one 2, then if q is equal to 0, then we'll have p cos 80 equals 250a. And similarly, if we do the same sort of thing in the second equation, we'll have p sine 80 equals 250g. And we're asked to find the value of a for which q is 0. So we could now, what we could do here is divide, this was our rearranged first equation and this was the second equation. What we need to do is, because we have a tan function, we want to divide the second equation by the first. So definitely do it in that way. And if we do that, then we'll end up with p sine 80 over p cos 80. So we end up with tan 80. The p's will cancel out. And just be very careful. You do need to make sure you divide in the correct order, so it'll be g over a. And that means that a is equal to g over the tan of 80 degrees. And of course g is 9.8, that's a g. So we can take g to be 9.8 meters per second squared and divide it by the tan of 80, and you would get 1.728 and a bit more. But remember, give your answer to 3 significant figures if you haven't been given any other information. So that means that a is equal to 1.73 meters per second squared. So if we just go back and just check on how these marks have been awarded for the whole question, then in the first part, part A, you got a method and an accuracy mark here for writing down, resolving horizontally, and then you got another mark, an independent mark there just for stating and writing down the resultant, or when you resolve vertically, so a B mark there. You then got a mark here for simplifying these equations here. Now this mark, that method mark was dependent on you getting the method mark up here. So you got a method mark down here and then an accuracy mark for putting it in the correct form. So 5 marks there. And in the next bit there were 3 marks for the second bit. So you got a method mark here, and you got a method mark here for tan of 80, and that again was dependent on you getting the first method mark. So this method mark was for eliminating p, and then an accuracy mark for your acceleration, 1.73 meters per second squared. So 8 marks in total. So don't forget that if you want to watch further revision videos, then you can do so by going to the FMSP website and following the link to online revision.